My name's Nigel Ashworth, the Solution Architect at F5. Where are your applications going to be? Well, quite often when we're presenting and looking at various architectures, it's where are those applications going to be actually located? They're going to be in our traditional data centers today, or they're going to move off-premise, or they're going to go into cloud-type environments that's there. So some of the questions we actually ask is, how are you going to protect them? What are you going to do when you're actually maybe hosting your own environment sets there? How are you going to move it on? And how are you going to go and get better scale in terms of either your applications or reducing your cost components on it? So if we generally look at the items which are out there in the marketplace today, we find that things are changing quite dramatically, or have been changing over the last 3 to 4 years in terms of that environment set there. There's lots of environment set things that are done there. Obviously advanced threats in there, but also lots of things in terms of the actual way that we deliver the actual applications, especially through HTTP these days. Other things that are changing quite dramatically is that we used to design and architect components for by application, by silo. The guys that were doing the Oracle were completely separate to the guys doing the SAP or doing the Microsoft Exchange components. So they were siloed into their architectures. The APIs side of it, though, is the thing which has been driving a lot of it. They want to do more of it automated in those components. So APIs have become a predominant part of the way that we deliver an application to the end user. Remember this type of environment? This was a few years back. We still do it, though. It's actually a good tested environment set there. But things changed quite dramatically, didn't they? Especially when software as a service and cloud architecture started to evolve. Now it starts to go round our actual security components, and we need other ways to actually understand where our perimeter is and how to defend against it. You look at the actual ethos of what we've really got to do. If we're hosting an application or offering an application out, then we've got to make it very secure. We know that. We've also got to make it fast. We've also got to make it highly available in that environment set there. Okay? So the fundamental word there is application. If we look back at what's happened in the last 2, 3, 4 years in terms of that environment, what worked and didn't work. Some of these things you'll find here, the agile development, speed to the customer, quality of application development, getting it to the market quicker type environment set there, kind of failed on rapid deployment models. There's a number of barriers which we came up against which didn't allow us to actually deploy it really quickly and really fast. Cloud and DevOps. Accelerate the time to market. Again, how do you take a security policy which you've already got in your own data center and then push it out into a cloud environment and make it stick out there? That was some of the problems which we had while trying to do those types of moves in that environment there. SDN. SDN in terms of an architecture, great putting it into the software components, but what about the middle stuff between the applications, the actual layers 4 to 7? What are we going to do in that components of it, and how are we going to deliver that? Those were sort of forgotten about when the marketing side of it got put into the actual system there. Okay? So those are sort of 3 main areas that hopefully we'll start to address over the actual next few slides, giving an inkling of how it can actually be implemented. So software-defined application services elements. 3 main elements here. The first one we'd look at is just a high-performance service fabric, and the actual idea that we've got a fabric that we can actually take data through and gain information on it. An intelligence and services orchestration component. Now, these aren't the orchestrations that from the Cisco's and from the VMware's type of environments. They're effectively orchestrating the application and the services onto it. We'll look at that in a bit more detail. And also simplifying a bit of the business model components, making life a little bit easier for the way that we actually put it into this service. Do we now buy licenses for our product, or do we buy it by the hour or the day component sets there? A high-performance service fabric, what does it look like? Well, it needs the network. It still needs the network. So we'll still be actually utilizing all of the actual infrastructures on our layer 2s and layer 3s that we're used to today. Okay? But actually what we want is something which sits just above that, and as it sits above it, it will then inspect all of the actual traffic. It knows about all the applications going past and through it. And that's the whole principle of it here. It doesn't make any difference if it's virtual, if it's actually on an appliance-type environment, or it's on some chassis-type components, or a mix and match of them in terms of scaling them out and adding the components there. But the important thing is that all that data actually flows through it. It can see it. Why does it want to see it? Really because of these three areas. It needs to have the ability to have APIs to be able to actually look at the data plane. Okay? So if we want to look at something, look at the actual data, transform it, and move it on at high speed, then we can do that. We also need a control plane to control where it's going, which data center, which services, and how it's actually going to get there. Plus also a management plane to report it and to have all the data set in there. But fundamentally, there's going to be a need for a programmability plane in that. That API these days is actually coming out as a RESTful API in terms of that environment set there. So that's what we talk about when we talk about a high-performance service fabric component. What sits on it? Services. Various different services that you want to actually apply. They can be security ones from a web application firewall, or they can be from a denial of service attack type of approach in terms of that and the policy. They can be to an identity access component. So what is your end user stance? What items are you actually utilizing? What applications do you need to get hold of? Availability, something which F5 is probably well known for in the past, is its ability to look at high availability systems in terms of traffic management. Mobility, knowing if you are on a mobile user, what actual services do you need? Commonly, if you're on mobile, you're probably into 3G and 4G type environments. What are the issues and sets that you have there in terms of making it faster for the end user to make life a little easier for his end user experience compared to when he was in the data center and pretty close to his servers? So that also comes into the performance aspect of it. But there's lots and lots of these services which are available there, and you mix and match which ones you need on which application. And the art here is choosing the right application, the right service for the right sets of applications. Traditionally, when we designed data centers, we would leave applications behind. What do I mean by that? Commonly, we would have a budget to actually go and put the Exchange on, or there'll be a larger budget to put the Oracle on there. But some of the smaller applications that really weren't budgeted particularly well probably didn't get any services or much services in terms of security, or they didn't get much in terms of acceleration components built onto it. It just wasn't part of their makeup and the nature of those applications. So we ended up creating a number of silos at the bottom with applications. But actually, those applications were quite happy in our data center, but they actually could do with some security components or applications and services put on there. If you're going to do it for the major ones, you can also very easily, very simply do it for the actual smaller applications there as well and bring them on board. And really, it doesn't make any difference if it's really going to be within our data center, or if it's a hybrid type environment set there, or if it's actually going into a private cloud component there. They should be right the way across the board. So, software-defined application services. Fundamentally, though, it's a lot of different services. You choose which service you actually want to put onto that environment there. If I was looking at a denial of service attack profile, for example, we might look at one or two of the slides a bit later on. I certainly want to look at web application firewalling, zero-day attack protection. The next thing I'd like to look at is the whole idea and the concept of layer 4 and SSL security. Not just in terms of scale and performance, but how do you secure the actual SSL itself? Okay. Then I'd also want to look at the DNS side of it in terms of security. How weak is it DNS in terms of the environment as an attack vector? Extremely weak. It's only an IP address and a query in there. You can attack it very, very quickly and easily. And we've seen some of the largest denial of service attacks happening in that area. So these are all just services that are available. They bluntly come into about 5 different types of services that you can apply. We'll look at some a bit later on. So one of the other things you need here is not just the fabric. You need to be able to actually control it. And to control it in 4 different ways, really, generally. I've shown it at the top here as the orchestration connectors, the OpenStacks, the Cisco APIC type environments, and the integration we're doing there on that environment. Basically being able to integrate and have them either control us or us send them information. Again, that's a two-way environment set, and it's really about utilizing REST APIs in that environment there. Cloud connectors. If you want to go to virtual editions, Microsoft Zen, KMD, AWS, and all those components, then why not have the connectors built for all of those components? Module connectors, going a bit closer to home for our technology, but actually managing all of our products as they go through and managing the application flow through it. Finally, multi-tenant or bare metal provisioning type environments and the connectors for that. All of this architecture needs those 4 sets of connector components built into it. You'll use some of them at some point in time, but other people will use them in different architectures and different components here. But fundamentally, they're the 4. And it's a different business model. A business model in that traditionally we used to buy hardware, we used to buy a license to run it, and we'd run it for 3 to 4 year type environments. But actually, when you look at synthesis architectures and general agility architectures, you need to have both buy your own, but also you want to borrow and utilize a license for a short period of time, hours, days, weeks, whatever. Okay? They want to be able to give it back and basically not pay for it over that period of time. So the actual architectures and the actual licenses need to be a lot more flexible in that environment. So synthesis is really about a high-performance fabric. It's about orchestration, and also it's about simplifying the business model that we've got. Let's put into a couple of examples of that. So what I have here is a data center on my left-hand side, fairly traditional one in terms of that environment and architecture. In the center, it's more of a hybrid. It might be our disaster recovery environment, but it's certainly away from our data center that we traditionally utilize. And then on the actual far side, we've got a public cloud type technology set. So completely not owned by us. I've also got a group of applications. Those applications are there for new delivery. They're coming down the pipe on a regular basis. How do I deliver this actual new application onto a suitable architecture? On the right-hand side, I've got a load of services, a group of services. And I want to apply those services. I can apply one or many, or I can apply just as a complete profile based on which application is out there. So an example of that. I want to take LTE and have an application in-house, and I want to give it better user end performance for that actual end user. So I just apply the acceleration type policy there. I take another application and I put it into the data center, and I wish to scale that. I want to add more performance on it. Maybe it's virtual capacity, or if it's standalone capacity. It doesn't make too much difference, but I'm scaling it out. I want to take an application which is existing in our data center today, and I want to put it out in the cloud, but I want it to follow and take on a complete denial of service a policy with it at the same time. So it's the same policies I'm using in-house as I'm going to be utilizing in my hybrid and in my actual public cloud environments. Getting the idea? 1 or 2 nods there. 1 or 2 maybes. So the whole idea of synthesis is that you can basically, as long as you can see the traffic, you can apply a policy to it or a service to that component set there. So when you look at the agility and the integration components of it, there are quite a few benefits that can actually be had by actually being able to move applications or services around or apply new services to those applications that are deployed. You can look at the stats up there. Basically, they are looking at how much it costs and how much more efficiency you can get out of it in terms of time saving, the actual cost saving, and the improved in the SLA type environments. When you look at the actual context of it, different approaches, it's going to be obviously the main 3 ways to consume a cloud, private cloud, hybrid cloud, or a public cloud environment. But actually, come on, build up. If you look at the deployment times that are out there and the way that you get a policy out onto an application, be it security, acceleration, or whatever type of environment there, actually time to provision a VM, 10 minutes, fairly easily, not too bad. Time to provision into the network components and get the policy set up, 1 or 2 weeks. Anybody recognizing this? How long does it take you to get a new application online, up, running, and working in terms of that deployment side of it. Infrastructure configured and services configured. Probably 2 to 4 hours, realistic. What I'm going to actually look at the infrastructure inefficiencies there, and if you could automate a whole load of that. And I'm including the actual security policies within that group there. Predefine the policies that I want. Predefine my security policy. I'll go through one a bit later on, which I did at a customer site a short while back. Once it's predefined, it's a catalog. It's a catalog of components. It's my denial of service. It's my web application component for it. It's my SSL profile for what I perceive and want there. So once I've got this catalog created, provisioning a VM, pretty quick. Same as before, nothing changed. Select the correct infrastructure and policy and put it on the catalog, or from the catalog. Should be able to auto-configure it in probably about 5 to 10, 15 minutes without much of a difficulty. So if you can see all the data and you actually have all the policies already set up, those policies can just be applied onto it. The infrastructure can follow it really quickly. And that's the whole principles and ideas that we're looking at this moment in time. That's how we actually deploy big IQs. This is how we deploy some of the application delivery controller components. And by the way, this may not necessarily be delivered directly by F5. It may well be by other third-party ecostructures. We just make it happen in the background in terms of applying the policy sets really quickly and easily. This is an architecture which is a reference architecture, and there are about 30 to 40 different reference architectures which you can choose from. This is just one of them, which is about a cloud migration architecture. It's about the top one is my existing data center. I want to then move to another data center down here. I've got my applications in the background which I can move over, but how do I manage all of the actual services and the components of it so that no users actually realize they're actually being moved over from a different data center to a new data center or to another cloud provider? So bottom line is we actually have coming on the left here, we actually utilize a lot of DNS in terms of its infrastructure to actually change and move geolocation and choose when the service is on and move them over. We also apply the actual application side of it, and we move across the actual policies for that. What I mean by that is how it should look, high availability, or it's SSL, or if it's actually all its security profile components there. And once that's over, and we've checked it and we know it's actually up and running, then we'll actually pass users into that environment set there. Probably very much similar to it, but actually a bursting. Everybody talks about bursting environment sets there. The difference here really is that you're doing it for a very short time, and then you're actually effectively bringing it back after a period of time. You've paid for that service or that component of it. You need to actually then release those components. I don't want to pay that bill next month or next quarter. I'll have that back in-house, and I might then want to go to a different provider and a different component of it. So just a slightly different architecture, but still based on the actual ideas that we need this REST API and this RESTful control to be able to push and pull the applications and the user and the services there. When you're looking at security policies and services, and you're looking at your applications components which are deployed there, how often do you think you're actually going to move an actual application out? When you move one out, how long is it going to be out for? So you have a mobile phone. That mobile phone you actually buy off a provider for a certain period of time. After a year or 2 years, you're allowed to change it after the contract's finished. And then you can change to a different contract with a different tariff, with a different amount of data on it. In these environments here, you're not going to be just looking at one data center. You're going to be looking at lots of data centers. So those data centers basically will have one of your services. You will push it out there for a period of time, but then actually you may well want to pull it back and then push it out to a different one because it gives you a better service level agreement. Your costs are different. Okay? Things change. It's more local, political reasons and rules. So what I talk about here in terms of architecture is that if you're going to have a security policy going out there, you need to be able to pull that policy back and then push it out to a different place easily and simply. Okay? It's quite often where a lot of people fail to actually have a lot of agility in their actual networks and the application deployments there. There's a whole group of reference architectures which you can talk about, a lot of them based around the security for the network, the application, and going into the actual detail into denial of service components there. what I did was I highlighted a couple of areas, and I thought it was suitable to actually go through some of those today. This is a very traditional security profile which we would commonly set up. What it shows is just, and this would just be one service at the end of it, so it would just be one thing which we would apply to any of the services which we have in the data centers. So I'd have a WAF policy, Web Application Firewall. So I'll be looking at layer 7 inspection environment, zero-day attack mitigation in terms of that environment set there, and making sure I understand that anything that's outside the actual web application is bad and we should stop that, and report on it at the same time. I will then have a firewall policy, certainly a layer 4.1 environment to set up for a whole load of your Apple's environment. I may well have a layer 3 IP reputational environment set up as well. Any IPs that are coming at me that obviously are well known, they have a bad reputation, I don't want them straight away. We'll get rid of them. A DDoS protection, both from layers 2 to right up to layer 7. That would be a standard policy, but that would probably include anywhere in the region of an inherited group of maybe 80 or 90 different settings or policies which are preset in that environment there. Bottom part, just a consolidation of logging environment. Once I've set that up in that one page there, I can then go and apply it to any of the services which are sitting there. And then if I wish to move that service, I can move it very clearly over to any of the other services and different data centers at the same time. That's actually a reference architecture for the actual denial of service environment. It's really very simple. It really just turns around and says, oops. It really says at the front end of it, you need to have high-end, high throughput capability, both for your actual normal TCP environments, but also for your actual DNS environments. Protect it there. So these are all of the attacks which are network orientated, or some of them are session orientated in terms of the DNS environment. Then at the back end and the block there, it's all about protecting the actual SSL components in my hosted environment here, and being able to actually create an ability to actually thwart any of the SSL environments. But at the same time, what happens when you actually have application environments? So it doesn't take much to take an application out. If you actually think things about like slow LORIS and slow post, they only need a few PCs to be able to actually stop a fairly major environment set there. It's not about brute attack in that environment. So the intelligent stuff is really the tier 2 stuff in that environment there. Could talk about the reference architecture for quite some time, but I'm just highlighting it in terms of what it is, and it's a built up really of a tiered type of architecture. By the way, you can, for smaller environments, we commonly build the 2 tiers together, so that they're actually one in one environment. And the nature of the attacks, denial of service attacks, where are they coming from, and what are the types are there? What we're seeing generally is that we see network attacks, but the network attacks just take out the network for a short period of time. They're a nuisance. They need to be dealt with. But when they're already sent to you, you can't stop them arriving at you. You've still got to deal with them when they get there. So scrubbing and high-speed environments normally sort some of that out. When you get into sort of the session areas, which is sort of the SSL and the actual DNS security components there, that's a different matter. How do you know if a DNS guy, or sorry, somebody's asking for a DNS resolution, if he's good or bad? Incredibly difficult. The only information you get on him is basically that he's an IP address and that he's got a query request. And both of those can be faked pretty quickly and scaled out and amplified out. So the session environment here for the SSL and the actual DNS is very difficult to actually look at, and needs specialist equipment and specialist hardware to actually go and inspect it and be able to actually prove there's actually somebody behind it that actually is requesting a real request into the data there. And then we've got the application side of it, which is looking at really what's the nature of the application, how is it built up. If I've got a form and I've got a request going into it, is there a SQL injection inside the actual form, or is it actually the correct right of format that we should have in there? So knowing how the application works. So network, fundamentally, is just really about the speed of the actual network and the components there. The DNS is really about bringing some intelligence into that to know who's good or bad in the environment. SSL, not just the capacity of it, but how secure is your SSL? And we've heard about that over the last 6 months in terms of the actual breaches which we've had on that. And then when you look at it, the application side of it. So those 4 areas are really the actual what we call a policy. There's different arguments to actually the argument if you actually would take it in-house or if you should take it out-house, off-premise environment, and provide other people. Fundamentally, it comes down to an SLA. What is your SLA that you've actually negotiated and have running and working with the actual provider that's out there? Most of the SLAs don't look at high availability and the security at the same time. Okay? They'll provide you one or the other type environment set there. So what I can say is that you're going to take it out service, there's some strengths and some weaknesses on it. If you actually look at it on-premise, there's a whole load of other strengths and weaknesses. Again, I'll let you read those slides, and you can look at it in more detail, maybe after the event. However, on this environment here, what we believe is that you should have both. You should be able to protect your own applications in-house, but you should also have the scrubbing capability or technologies that can be moved out externally. So remember, I talked about the idea that we have this. I think actually it's the next slide. No, it's not. Let's skip this one. Come on. I've duplicated a few slides. Sorry about that. I talked about this idea that you can take a policy which you've created, which is a number of services on the right-hand side, and I can actually pick that service and just move it over. Once you've created those services, it should be literally able to actually pass it over to that application or that component set there. Okay. So since this comes down to 3 major components, this idea of the ability to have the fabric in the data center. Once you've got the fabric in the data center, you can have the orchestration components of it. You need a simplified model to be able to move applications and services across really quickly. But then you can create those services yourself. They can be security services, but they can be also other services components as well. And those services then can be applied to each and every application that you actually are sitting across that fabric. And it makes life so much easier to get an application deployed. And also, through the automation, allows it much simpler in terms of costing as well. I think that's just about all of the slides out. Sorry, I did duplicate some of the slides there. I didn't realize that I'd actually cut and pasted in a few extra ones there. But that's really the principal component of it, in terms of that environment set there. Any questions on that? Deathly silence. You either didn't understand any of it, or you're very polite and very quiet. No? Okay.
I actually have one question about how specifically F5 is dealing with DDoS attacks. I mean, in terms of the nature of like.
How do you deal with DDoS attacks and the main features of it? One principal thing about DDoS is that actually it's a blended attack. It's lots of different environment sets there. We're not seeing just one attack pattern on a regular basis. We're seeing smoke and mirrors on a regular basis. So we're actually seeing attacks both at the actual network side of it, the actual SSL, and the DNS side of it. And probably the one which is the most important one for us commonly is the attack which actually isn't necessarily an attack. It's the way they get to go through at the application layer. So you've got to actually realize that you're being attacked, mitigate those other 3, but track that other guy that's coming through, which maybe look like it's a completely legal request just going through to the application component, and how to actually deliver that, check what he's doing, and making sure that he actually isn't trying to grab those credit card numbers and details. So from our perspective, it's smoke and mirrors at the bottom, but actually at the application layer, it's the most important part about it. Yeah? Anybody else? It's the end of the day, I can tell.
Okay, then probably we should start the coffee break.
Okay, thank you very much. Much appreciated. Thank you for your time.